Autodesk Simulation CFD is natively integrated with SolidWorks. This means that everything from geometry to material properties are able to be completely linked between the two products. To work with this geometry, you can either choose to use the active model, which is the model on the display screen, multiple configurations for design changes, or CAD entity groups. With the model exported, you can see that the CAD geometry inside of SolidWorks was brought over, but in addition, the negative space was filled by a volume which will represent the fluid, in this case, water. You can see that the material properties were already sent over because of rules that were set up inside of SolidWorks so that the material properties can go from SolidWorks directly to Autodesk Simulation CFD. Next, we need to apply some boundary conditions. In this case, we're applying a volume flow rate to tell how fast the volume of water is moving, followed by a pressure on the other side. This tells us where the water is going to be moving from and where it's going to be exiting the valve. With our loads and boundary conditions applied, we're now able to solve the model. By clicking on the Solve button, we can determine how many iterations we want to converge on our solution and then press Solve to analyze. We're now able to review our results. The default results is velocity magnitude. In addition, you can change the global results to many options such as static pressure. Some of the real power in evaluating the results comes from adding such things as flow lines. If we look at the velocity trace lines, we can see how fast our fluid is moving in a location and where it may be swirling around. You can also view this as velocity vectors to see what direction the fluid is moving. In addition, you can do such things as look at the pressure on the poppet, where we can then determine if our part is going to chatter and make a lot of noise. Another great thing is the Decision Center. Here we're able to evaluate all of the different designs that we looked at and evaluated inside of Autodesk Simulation CFD. As you can see, we have multiple scenarios set up, and when we move one of them, the other ones will move to match this. This will allow us to easily view all of our results and compare them to make sure that we know which design is the most efficient for our use.